All right, good morning, guys. Joseph, you're here. Good morning. Um, Today we will be talking about a very important concept, and that's malloc. Can you hear me? If you can hear me, please say something, so I know somebody can hear me, can confirm this stuff. All right. So today we'll be talking about a very important concept, and this is malloc. Malloc is memory allocation. That's the M in front is like memory, and alloc is for allocation. That's how it was named. Malloc is like memory allocation, and it's a very important concept in C programming. I'm rushing because our class today has to be a little bit short, but then I need to convey the information that I want you guys to have. I need to ensure that you have it. So, malloc is memory allocation. In C, we have to allocate. Okay, so far on this training, we have been declaring variables and issuing data types to them without telling the computer how many we've been telling the computer how many bytes to allocate to each uh, uh, variable that we create. We know that characters are like 1 byte, integers are like 4 bytes, so the computer creates like 1 byte to 4 bytes for each character. But then when we do strings, we tell it how many characters we want the string to have, so we hard code that. Now when we are writing code, you know many a times in a professional scenario, you would not know the amount of values that will be stored in an array. So because we don't know, we'll be generating them on the fly. We want the computer to actually calculate how many, you know, bytes that the array requires to store all the data that it's going to be containing. And this is where memory allocation comes into play. you know it's a very important concept in C programming, and you need to understand the fundamentals of it, how it works. You clearly need to allocate memory for every variable, for every array that we create in C programming. Memory has to be allocated to it. The computer, usually how it works is the heap. There's what we call the heap at the start. The heap is like a chunk, a chunky yard of memory where the stack borrows from to save our information. So what we are doing each time we hit up the operating system to create or to save something in the operating system, they are being saved on the stack. But then the stack on its own does not actually have space on its own. The stack borrows memory, borrows space, you know, from the heap. Well, there are all of these things that I'm explaining. I've tried for you guys to understand this, so I included them in your materials, the materials that you are going to that you are supposed to have covered before you show up for this class. uh yeah, without saying much more, we need to understand how memory is being allocated. So let's dive right into our what do they call it for the day? mm, Whole computer. Yeah, I guess you guys can see my screen now. Yeah, so that's it. We have like a lot of code to write today. I want this class to be exactly 1 hour at most. We have a lot. Yeah, so we are to be doing memory allocation and all that. Where should we start? Let's just jump right at it. You guys should have taken time to have read all the information. I don't really have time to start going through the information. Yeah, so malloc underscore checked. Write a function that allocates memory using malloc. Write a function. Our function should allocate memory using malloc. And this is the prototype void. I told you guys about prototypes. We need to clearly define the prototype of every function that we we write. If you've noticed, we are using functional programming. We build like a function for every single functionality that we want our program to have. It's a very good way to write code. Don't worry, we'll be learning object-oriented programming very soon when we get to Python. But for now, this is functional programming. We are writing, we are defining, we are clearly defining all prototypes in a script called main.h. We are bringing in main.h to the current script where we work, to where our main.c is, and then we are calling all the functions that we've written that main.h knows where they are and knows they are as defined. We are calling them into our current main.c program. That's the basic structure of the code we are writing in C. And we'll soon be doing a project. If you look at it, you have a printf project and you have uh, a shell. You build a simple shell program in C. After then, will I start calling you guys tech bros? For now, I've not been using that word on you because you've not built your first program. When we finish building, you can now see yourself as a tech bro. Well, so first things first, let's create the prototypes that we need for this program. Uh, let's make a directory here. I need to make this be my entire screen. So let's make a directory called malloc, right? We go into malloc. So there's nothing here. We are good to go. First things first, we need to make the main.h file and clearly define the prototype, right? So vi main.h. Yeah, and remember I told you guys that we want to only run the main.h file if it is not already in existence. So what we do is, if we say if not defined, that's the only way we want to define it. If not defined, main underscore h, then if the main.h file is not defined, we want to define it underscore h, and then the last thing to do here is to end if, right? So first things first, uh what do we need to do? We need to put in the prototype. Let's put in, we might be using the put char to bring things to the screen. I don't know if the program allows you. I didn't read the information this morning. I don't know if the code allows us to use the put char. So we are put charring C, but we'll find out in a bit. For now, let me just put it there. This is our put char function that we've used over and over again, if you remember. What was the prototype for the first function? Let's go check it out. Yeah, this is it. So this is it. Let's just copy and paste this in. It's going to return void and is a pointer malloc underscore checked, and it's having an unsigned int. They are saying that it should return a pointer to the allocated memory. Okay, that's simple. They are saying we should just return, we should create a malloc. We should write a function that allocates a memory using malloc, that allocates memory using malloc. Let me see you guys. Know if um, I'm talking to people. Oh, okay. Somebody says they can hear me. So I'm good to go. I am good to go. Yeah. So I guess I copied this. Let me copy it again. Forgot. So it says write a function that allocates memory using malloc. So we are building a function that allocates memory using malloc to an unsigned int. and the unsigned int is going to be b. They are saying return a pointer. Our return value should be this, the pointer of the to the allocated memory. And then they are saying if malloc fails, like if it fails to allocate the memory, so this is very simple. We should return uh 98. Hmm? We should normal process of termination and status value 98. Okay, that's really simple. And okay, let's go write this simple block of code. So first of all, we paste this here, so we know that we've defined our main.h file. And what next? What next? I forgot to check the name of the file required. So the name of the file required here is 0-malloc underscore checked. 0-malloc underscore. Hope you guys are saving your stuffs clearly. This thing is a repository still in low level language, and this is the directory you're supposed to be working with. Don't go create a malloc, ordinary malloc directory like I just did. Make sure you're using the right things. Yeah, so 0-malloc underscore check dot c is the right name. So let's do that. Vi 0-malloc underscore checked dot c. Yeah. So how then do we start? I think the first and most important thing is for us to start by including all the. Okay, first of all, we made the main.h file. Main.h, we should include that. What else do we need? We are going to be using malloc. Malloc is in the standard library, so we have to stdlib, dot h, right? stdlib.h. Yeah. So that's it. Remember to always write a comment that you use in remembering what you are trying to do here to, like, teach yourself later on. But then for me, I don't need a comment here because I don't know if I might be going back to this stuff ever again. This stuff is now within me. Yeah, so what do we do? The thing was returning a void, and it was a pointer to malloc underscore checked, right? And it was an unsigned int, right? Unsigned int. Yeah, it was an unsigned int. Can't remember what was the letter there. Unsigned int b. Oh, okay. It was an unsigned int b. Yeah, so this is it. Remember when I said they say we should return, we should have a return value, and our return value should be the memory that the the pointer creates, right? Okay. Return. Let's return the memory. It's supposed to be a pointer. We'll make it a pointer here. So yeah, first things first is void uh pointer mem is equal to, that's what they say we should do. We've already called the standard library for malloc, so we have the permission to use malloc, and whatever is passed into b is what should be here, right? So that's it. We've done this. Before we should return this, we should have another return statement saying if this was not working, if this didn't work out. So in essence, if mem is equal to null, if memory was not allocated to this guy, we want to exit this program. That's what the say terminate the program with a 98 return value. Yeah, so this is the function that we were told to build. Here this was our prototype. It was taking in an unsigned integer called b. B is an unsigned integer, and the void void here, uh, void mem is equal to malloc b. What this does is it takes in uh, a space in the, it creates a space in the memory. It does not allocate anything to this space, mem. It calls it memory, and it creates a space for it. And then int here is just telling the computer how many bytes, you know, and how many bytes of memory to create in the computer storage and store it inside mem. So this mem is a pointer to the address of this allocated memory with size of b. All right. And then here we are saying if the memory is null, if there is no memory, if memory does not exist, exit with a 98 return value. But then if it exists, then return main. So this return is not going to run if this condition is true, because it's already going to exit the function. All right. Let's go. Let's go look at let's copy our main dot the question. There's a main.c file that I've provided here for you all to use and test your code. So these are main.c file here. Let's copy it, right? And then let's do cat 0 dash main.c. We'll paste this in here, Control D, and then let's let's run the code. We are running it into a file called A. So you can see we are creating a bundle for 0 dash main.c and malloc underscore check, and we are printing our output to a file called A. Hopefully there's no errors. There are no errors. We created a simple memory. Yeah. So if we run A, you are seeing that we are having the exact same output on your question. These are addresses to memory, right? Where is this stuff? So this is it. See it here. This is the correct output that you should be getting, right? So if you just run nothing, you're supposed to get 98. Print out on 98. Okay. Um. Yeah. I'd love to explain this main.c file to you so you understand what main.c file is doing. Where is this stuff? Yeah. So let's clear this out and let's cat main.c 0 dash main.c. Yeah. So 0 dash main.c is including main.h. It is including standard IO because it's going to be printing out something to the screen. It's as well including the standard library and limits.h. I'm going to explain to you why all of this stuff is needed. So first of all, it's uh, creating memory using our function uh, for C. It's creating memory for character C, first of all. Character C is a pointer. And here, what's going on here? What's going on here is we want to know how many bytes to create. All right. Because we want to know how many bytes to create for malloc to, we want to know the size of a character. The size of a character is 1 byte multiplied by uh 1204, and that's how many bytes of memory that is being created here. We are doing the same thing over and over and over for all of them. You know, we are just creating this standard practice. When you see this, don't get confused. This standard practice for in C programming. Each time we want to print out a memory allocation, space we allocated for to a value or a variable or anything. This is just standard practice. Void asterisk and then the value. So don't get confused when you see this. Okay, go and read your materials. It's there in one of the materials as well, saying that this standard practice. So if you see, we are doing it for each of the values we want to print out. We are saying void that void, yeah. So free is how we free the memory being allocated to the uh, uh, being allocated to these variables. Okay, the space being allocated to these variables, if you don't free them, they would always keep, they'll be there, they'll be stored there. And sometimes even when you free them, we still need to set them to null so that you don't get like an error later, because the computer, see, is very unforgiving. The computer might uh, still be harboring some form of information on the data that used to be there. So after freeing memory, sometimes we still set it equal to null just to be sure that it's completely free. Um, let's clear this up and see what the next question is. Uh, question one, on the other hand, is saying write a function that concatenates two strings. Yes, I want to do this for you. This involves some level of, I've shown you this. Basically, this is all there is to memory allocation, man. It's allocating memory and declaring how many bytes that you want the computer to allocate. You know, so I'm going to do this one for you. You know, I'm going to concatenate two strings, and it will teach you at least a lot. Let's see, where's the prototype. This is the prototype here. Let's copy it to our main.h file. And then and then we've copied that to our main.h file. What's it saying here? What are we supposed to do? So they are saying concatenate two strings. We've done this before, but then we'll do it again because of memory allocation. Okay, I'm going to tell you something. Okay, the return pointer shall point to a newly allocated memory, which contains S1 followed by the number of bytes of S2, and the no and is null terminated, Okay, so basically what this is saying here is that the pointer that this should return, our return value here is the character, and it's going to return, the character is going to be a pointer, and what it's going to be is it's going to contain the value of S1 and then n number of values, the first n values of S2, of character S2. So imagine that our string is hello world and n is 3. This is supposed to be a hello, this is supposed to be world, and n is 3. The return character that we are going to, our return value is going to return hello in full, and then the three first characters in world, which is WOR, right? So that's what this is saying, right? Then they say if the function fails, it should return null. If n is greater or equal to the value of S2, use the entire string. If n is greater or equal to the length of S2, then use the entire string of S2. Right. So if n is greater than S2, we should use the entire string, which is normal. So if n is less than S2, then we should use the number of n values in. Yeah, that's what I explained earlier. So if the null is passed, treat it as an empty string. Okay. If null is passed, treat it as an empty string. So all of these statements, we use if statements to treat all of this, right? Um, what is this place doing? It's just passing our function and it's concatenating it. Okay, so having that been said and done, This is a very simple one as well. I'm going to fix it. We already put this in our main.h file, right? So let's still have this copied. Still have this copied. Yeah. Oh, what was the name of that file? It was supposed to be one dash string underscore n concat via one dash string underscore n concat dot h. Okay. So this is it. What we want to do here is we want to first include our main.h file, right? And then next is we are using malloc, and like I told you guys, malloc is in the standard library. Oh, we have an error. Malloc is in the standard library. So next we want to include standard stdlib.h. Yeah. So what should we do now? I copied that prototype to make things easy for us. We don't have time. We have this class has to be less than an hour or 1 hour at most. So it's easy for people to just look at it and get a hang of it. So what do we do here? Um, First things first is saying the question says the question says uh the question says the return pointer shall point to a newly allocated space in memory which contains s1 followed by n bytes of s2 and is null terminated. So first things first, we don't want null values here. Okay, if the function fails, it should return null. If the function is if n is greater than or equal to the length of s2, use the entire string s2. If null is passed, treat it as an empty string. Okay, so first of all of this stuff is null terminated. So s1, where is this stuff? So first things first, we want to say if bracket s1 is equal to null, right? If s1 is equal to null, what do we want to do? We want to say let's create a value that we'll use in running through the string. We have two strings to run through. We have string we have string s1 and string s2. So we'll create the value we want to use in running through each index of s1. We'll create it as I. This is how I'm thinking about it. I'm thinking about it as I do a for loop to run through every single character in string s1. I do another for loop to run through every single character in string s2. And then I create another variable where I'm going to say, I'll use a for loop to say for each index of s1, save it in my character, and for each index of s2, attach it to the same character again. So it forms the full string. So this is my idea, right? I told you programming is all about uh, you, the programmer. You need to solve the program, solve the problem in your head first. So what am I trying to do? I'm trying to save. I'm going to do a loop to save the total number of characters in S1 in a variable called, let's say, let me I think I should be, as I'm explaining to you, I should be initializing it. So these are unsigned ints, right? So let's create an unsigned int, unsigned int, right? I. Now for unsigned int I want to store the total number of values in S1. I'm still going to use let's say J to store the total number of values in S2, right? You store the total number of values in S2. And then I'm going to use like okay, let's do that first. So we'll do that first. So if this is not null, what we want to do is we want to say I is equal to 0. If this is equal to null, we want to say I is equal to 0. So next thing, what if it's not null, right? If it's not null, then we want to increase the value of I. Let's say else, right? If this is not null, what do we do? If this is not null, we want to do a for loop for I equal to 0. So we are initializing I as 0 here, and then we are saying if I is less than, if I is, no, I plus plus. Okay, for we want to check for each value, right? There's no need to say if I is less than, we can still do that. We can still do that. Let's see. Let's see. S1 index of I, right? Yeah, yeah. I think I have it clear in my head right now. So I plus plus. Let's say I plus plus here. Let's say I plus plus, and let's just end this line of code. We are not doing anything, so we do nothing, just end it. So basically, what this is I'm saying I is equal to 0. If this is true, if there's a value in I 1, we should increment this, right? So if this is true, this is a conditional statement. Don't forget. So basically, I is equal to 0 here. For this, if there's a value in S1, like if there's a value in S1 I, we should do I plus plus, right? So it will keep checking and keep increasing the loop till the loop gets to the end. And this loop is not doing anything, it's just counting and incrementing the value in I, you know. So at the end of this statement, I becomes the total number of characters in this string S1, right? So we'll do the same thing for J. We'll do the same thing for J as well. We'll say if S2, we want to know the total number of strings in S1 and S2. So that's why we are doing this. We are checking if it's equal to null, set I is equal to 0. If uh, it's not equal to null, then count the total number of characters in S1. We want to do the exact same thing for S2. So we are saying if S2 is equal to null, if S2 is equal to null, we want to say is equal to J is equal to 0. I want to set J as 0, right? And then like we did earlier, we need an else statement. We need an else. Did earlier, we need an else, and this else is for a for loop, like we said, and this for loop is not returning anything. So yeah. So what are we saying here? We are saying j is equal to 0, and then the next one here is for s2 to increment to the end. So if there's a value of in s2 at position j, I want to say j plus plus. Yeah, so this is the function we've been struggling to build. So now we know the total number of characters in string s1 and the total number of characters in string s2. They are both stored in I and j respectively. Yeah. Let me see you guys. You guys are following. Oh, okay. You guys are following. Okay. So they are both stored in I and j respectively. Okay, I'm getting like message. So yeah, they are stored in I and j respectively. And what's next? Shall print newly allocated memory Okay. Um. Yeah. So the next thing we want to do now that we know the total number of values in I and j respectively is we want to know if the total number in n in this is greater than this or not. So remember, if this is greater than this, we want to print this number of this number of the first n number of characters in string s2. If n is greater than s2, then we want to print the entire s2. So that was what the question required us to do. So what do we do? This is a simple if statement here. If j is greater than n, right? J is the total number. Don't forget, j is the total number of strings in s2. So if j is greater than n, what do we want to do? We want to print. Okay, if j is greater than n, we want to say that j is equal to n, right? If j is greater than n, we want to say that j is equal to n. So we'll print only j values. Do you guys understand yet? I know my brain is seeing this thing. I'm the one thinking about it, so my brain is working here. So if j is greater than n, we want to say j is equal to n. That's simple. Remember, j is the number of values in s2. You get. So if we are printing j values of s2 and j now is n, it means that if n is 3, we are printing 3 values of s2 instead of the total number of values in s2. So this is the simplest way for us to do that, right? Now, what do? We want to create the function. We want to use malloc. It's time to start using malloc to create the function. So what do? I think we should, first of all, we should create, yeah, we have the place that we are going to store this value that we are creating is going to be a character, right? So let's create a character s where we are to save this. So it's the pointer to the address of you know s in memory that we are creating, and this s is where we are going to is the space that we are going to create to harbor all of this s1 and s2, right? So what do? We want to say s is equal to the malloc is equal to malloc And what is the size that we want to create? How many bytes do we want to give to S? We want to say how many bytes? The total number of bytes that this our function requires to create to save character S1 and S2 is, we first of all know the size of, okay, let's say size of car, right? Size of character, size of a character times, these are all characters. S1 is a character, S2 is a character. We want to know the size of a character multiplied by the total number of characters in S1 and S2, right? Size of a character multiplied by the total number of characters in S1 and S2. That's what it should be. So size of a character times, let's say S1 plus S2. Sorry, total number is I plus J plus J. Size of a character, don't forget, size of a character is 1 byte. So 1 times I, if I was 5 plus 6, if J was 6, will be 11. So it's going to create 11 bytes for all of this. And yeah, that thank God I just checked this stuff. There's still going to try an error. We need an extra space for the null, the end term of an array. So we need an extra byte for that. 1 plus 1. That solves that problem, right? Remember, every array that you create has an end term. The end term is that /0 that I told you about. So plus 1, that creates the perfect size for whatever values that we put here. Whatever values that we put here, whatever values that we put here. Right? Um that's for that. That's we just successfully created our space in memory for this stuff. Now, the next thing that we want to do is we want to check if this space is created. If S is equal to null, if S is equal to null, what do we want to do here? We want to return null. That's the question said if the where is this stuff? If the function fails, return null, right? So we want to return null. We have to return the null, right? So if the function fails, return null. Now, if the function does not fail, so now we have the memory that has been created. So what do? We want to save something into the created memory. Wow, I feel really tired. I feel like stretching out. So we are almost coming to the end of this class. This is the most complicated one. I'm using malloc to solve. We've created memory. This is the most important thing that you need to learn today. What we did here. This is the most important thing. How to join strings together and all that using for loops and if statements and all that. I've taught you guys this stuff, and I expect you to be able to do that. This is why I came here, to teach you how. I'm going to explain this. When I'm done with this, I'm going to explain it very well, and I hope that it helps you to clearly understand. By the time you take out your time to learn this alone, I think you'll be able to understand the concept of memory allocation and use them to solve little problems. Very soon we'll start solving more complex problems. We'll start building things, building websites and all that. This is just to open your mind, to make your minds, work when we get to those times, when you start doing backend and all that. All right. Check live. Yeah. So yeah, the question said return null if S is empty, in essence, if the memory was not allocated. So we've done that. We've written a function that returns null if the memory was not allocated. Now that the memory is being allocated, we want to, what do we want to do? We want to, we want to Basically, we want to save all the values of S1 and S2 into S1, right? We want to save the values of S1 into S1 and the values of S2 into S1. So how do we do that? How do we achieve this? We do that by doing a for loop and going through all the values uh of 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 S1 as well as all the values of S2 and saving them into, let's say, S1. So what am I talking about? Let's do a for loop. It's very simple. Let's do a for loop. And in our for loop, let's say that uh uh okay, we have to create another variable. Let's create a new variable, another unsigned int. We've used I, J, K, L. No, we'll not use L, let's use K. Yeah. So we want to say for K equals 0, right? For K equals 0, if K is less than I, which is S1, if K is less than S1, right? We want to say K plus plus. We want to increase the value of K. Yeah, we want to increase the value of K. And then for each of them, we want to save inside character S that we just created inside the memory. So when K finish counting for S1, we'll count for S2 and save everything in S1 into the memory that we created S. Yeah. So we want to say that we've looked through K and we are checking if K is less than I, we are incrementing the value of K. The next thing we want to do here is we want to say S, the memory that we allocated at position K, we should be counting from position 0 of I right now. At position K is equal to S1, right? I will explain what I'm thinking right here. Yeah, that's it. This solves the problem for us. And then we'll do the same thing for S2. We'll do the same thing for S2. If K is equal to 0 and K is less than J, remember J is the total number of values in S2, and K is less than J, we want to say K plus plus. So this time around we are using S2, not S1, right? So we want to say SK. Okay, we want to check the values in, this time around we'll say SK plus I, S index K plus I is equal to S2, right? Right? Okay, so what have we successfully done here? We are successfully looping through the we are successfully looping through the total number of we are looping through K if I if k is less than I, we want to keep implementing k. Now for each value of k, we are creating indexes in I and we are saving things. For each value of k, we want to say S1 k. S1, remember, S1 is a string here, right? So we want to say S1, for the first time when k is 0, we are taking the first index of S1 and we are saving it into S at index k. S at index 1 will now be S1, the second letter or character in S1. At index 2, when these loops increase to index 2, the third letter of S1. And we are doing the same thing here. So basically what we are doing is the indexes. The reason why I'm doing k plus I here is that I want the computer to have a different index from here. So there's no like, it's not replacing the value of k. That's why I'm doing k plus I. I want a different value, a different index of I for each instance of k when it's checking j. And then for each instance of k when it's checking I, I'm just using k here, but now I'm using k plus I to ensure that the indexes are different. That will make S to build the complete. Now, somebody would ask me, why is S2 not building, uh, would S2 not build the complete string? How does it? Remember, we handled that here. We are saying if j is less than n, then the total number of j should be the, if j is greater than n, then the total number of j should be equal to n, to whatever is passed here. So even if j is 50, in as much as n is 3, j here is now equal to 3, and here we are checking j. We've already changed. Yeah, so basically I feel like you understand this stuff. Go back and take some time to think about what I'm saying. So the j value, which is the total number of characters in S2, we are now looking at them here and we are printing them into the space that we created in the memory. We are saving them. That's what we are doing here. And then don't forget that the total number of j here, j is the total number of values in S2, but then if the value of j is greater than the value of n, we are making n the total number of allowed numbers that should be added to the memory that we created in S2 is what we are saving in j right here. Okay, so that's what happens. This is how we save to the memory we just created. Yeah, so last but not the least, what we want to do is we want to create the null term. We want to save the null term. I told you guys we added one here for the null term, which is usually the last value of an array. Remember in C, I told you we always treat strings as arrays. So S, remember it's now k plus I. No, 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 no. K plus I. K plus I has already ended here. K plus I has already ended. Um, the null term. K plus I has already ended. So J at the end of J. Okay, we just finished tackling J here. So it's at the end of J we want to add this stuff, right? So the total number of J plus the total number of I. Yeah, that's the null term. The null term is I plus J. That's how we get the last space in S. Remember, for indexes here, indexes start from 0. In essence, when we do I plus J, it's like the total number of I and the total number of J that we are getting. So there's no like last term. So there's like one free space, sorry. There's like one free space. It is at this one free space that we want to set to of the null term of an array. Yeah, so it doesn't throw any errors. And then at the end of this all, we need to return something. What are we returning? We are returning the memory that we have created, S, right? So that's that for that. That's that for this question. We've successfully created and returned. Let's save first of all, and let's go get the main dot. This 10 o'clock. Let's go get the main.c file for question one. What's the main.c file doing? As you can see, it's just calling our function concat here, and it's passing in best and school, and it wants to print only 6 digits of school: 1, 2, 3, 4, 5, 6. Remember, these other ones is not printing them. N is 6 at this point, so this is what our main.c file is doing. So let's go paste the main.c file as well. We say cat one dash main.c, and let's do this. Done. So gcc, yes, gcc. So let's copy this stuff. Too lazy today. I have to step out, so I have to be really fast. Okay, okay. Complaints. What's he complaining about? No such file as one dash string and concat. So what's wrong? GCC, we should have this file. We created it. One dash n concat.c. Oh, ours was .h. Oh, are you seeing this stuff? So let's mv one dash string, and let's put it into one dash string underscore n concat dot c. Yeah, so let's run this again. Okay, okay. So for the first time, C is giving us, we are having like a bunch of errors, and we are going to check on them one by one. So what's it saying? First of all, it's saying, mm, what's this? Example, run the test. Where is he saying this stuff? Okay, so we have like an error here. I saw that. So vi1 dash main dot c. We copied something extra. All right. So let's run this again. I know that we are going to still have more errors. Yeah, so the first errors has gone out. Now the next one is saying J is undeclared. So we use capital letter J when we declared small letter J at some places, right? And then there's something I'm seeing here. Here is saying we are using comma here. We are using comma here instead of like a semicolon, right? So you can see I'm not stressed. I'm quietly. I think the reason why this is throwing an error is because of this semicolon that we did use here. That's why that's throwing an error. So let's solve this one first. This is on line 17 and line 19 of our code. So like I told you, each time you have errors, don't feel stressed, don't feel scared or something. Just work on it, you know. So here we are using capital letter J here, and that's a major error instead of the small letter that we declared, right? And then here on line 19, we are supposed to do this, right? So let's go back and run and reduce the number of errors that we are having. This is the first time we're having so much errors like this. So that error is out, And now the next thing here, we are using size instead of size of, the size of stuff. And this one is complaining here. And I think the reason why it's complaining here is because we 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 failed size of as well. And then this capital letter K here on line 30. Let's solve that stuff. VI1 dash. Many a times when people write code, they keep testing why they write, and we've not been doing that. We've just been writing. I was expecting errors anyways, but okay. And then I saw a capital letter K somewhere. Oh, okay. So that's all of our errors. We no longer have errors. Yeah, so we can run this and see if we have best school. So that's it. We have best school and those apostrophes are no longer there. And this is the required output that we were supposed to have. I'm going to explain this code once more, because I feel like it's really important for me to explain it. And then I let you guys go do your assignments. Yeah. So what are we doing here? The code requires us to write a function concatenate string, and the concatenate string is supposed to add the value of s2 in and s1 together. And then the question says that if n number of characters in s2 should be added to s1, except the value of n is greater than the value of s2, then you should add everything in s2 to s1, right? In a bid to do this, we said if s1 is null, set I to 0. If s1 is not null, then calculate the total number of values in s1. And that's what we are doing here. We are saying s1, total number of values in s1. So we initialize I, and we are saying I index of s1. For each I index of s1, increment the value of I. So I at the end of this for loop is the total number of values in s1. And we did the exact same thing for s2. We said if s2 was equal to null, set j to be equal to 0. And then for j, you know, for each s index of j that is true, we should increment the value of j. So we know j is the total number of values in s2 at this point of the code. And then we handled the n problem. We said if j is greater than n, remember, j cannot be greater than n because it is n number of s2, which is j now. The total number of s2 is j. So it is n number of values in x2 whose total number is j that we are adding to everything that is in s1. So in a situation where j, which is the number of characters in s2, is greater than n, we want to only add n numbers instead of the entire j. And that's why we have this function. If j is greater than n, we are only adding n. We are making j to be equal to n. In essence, we only add j number, which is now equal to n, the total number of allowed numbers here. That's what we are doing here. Now that we know the total number of j and the total number of I, which is the total number of s and s1 and s2, we want to now create a space in the memory, which is why we have this class. This class is not about variables and functions and for loops and all that. This class is about how many, you know, bytes of memory that we want to save. So this is the most important thing in this class here. So s right now is equal to malloc, which we brought from the standard library here, size of, and we want to know how many bytes to pass to malloc should create in our os. How many bytes of memory should be allocated to S in our operating system? We are saying the size of a character, since S is the type of S is a character, size of character, which is 1 byte, times I plus J, which is the total number of bytes, 1 byte in S and S2. And then we need an additional byte for the n10 of the array that we will use to that will be storing in S. So this is a perfect fit. The memory that the computer is going to allocate to S will now be a perfect fit for S. It's not going to allocate, it's not hard coded. Anytime we create this function, the memory that is going to be generated here is going to be a perfect fit for whatever characters, number of characters that we put here and here. We are not wasting space anymore in our computer. This function is not wasting space, anymore. Now, we are saying if S is null, return null. That is, if the memory was not created, return null. But then if the memory was created, what do we now want to do? We want to start saving into S, which is this created memory, every character in S1 and every character in S2. And that's what we did here. We created a new uh, index called K, and we are saying for each index of K, looking at S1, we are running through S1. For each index of K, save it into S at index K. And then we incremented K till the end. At this point, we had saved everything in S1 into S. And we did the same thing for S2. We saved everything in S2 into S. And then for the additional memory that we added, the n10, we said the total number of I plus J. Remember, total number of I plus J plus 1 is the total number of space in S. If you understand what I'm saying, I is total number of S1, J is total number of S2, plus 1. We added 1 here when we were creating the space for the n10. So we are adding that to to the last term of yeah. So that's that. And at the end of the day, we are returning S. S is the values that was saved so far. So that's that for that. The class is an hour long now, and we are supposed to be ending the class like right now. So you guys should go, keep up, keep learning, keep doing this stuff. Use the knowledge that I just finished teaching you. Today was a memory allocation class, and I think so far we've clearly understood how to allocate memory. Um, Go and try. Create time for this stuff. It is a little bit difficult. It's really complicated. The computer is not helping us do anything. This is how you learn everything that's going on in your computer while you are writing code. You know, that's basically what I'm trying to teach you. I want you to know everything that your computer is doing, everything that is going on in the behind the scenes. Yeah, while you're writing code, while you're creating variables and all that. This is what computer science should be learning. This is what Nigeria is failing to teach. Practically, when you go to a computer science school or a university to study computer science, this is what they should be doing. You should be seated in front of a laptop. Nobody should be solving maths and physics. And man, this is the job. This is software engineering. This is what people should be learning, and not you come and solve maths, calculus and all that stuff. Anyways, that's that topic for another day. I'm not getting into Nigerian problem. But then this is it. This is what a memory allocation feels like. This is how to clearly define to the computer how many bytes of space to allocate to a function that you have created, or so that you don't keep wasting space. All right. So we've come to the end of today's class. Hopefully, you guys don't have any question, because I'm not seeing any question in the comment section. Right? Go and complete your assignment and keep posting them to your GitHub. right? Don't forget to submit to your GitHub when you are done. All right. Do have a good rest of the day.